Okay, welcome to Programming Rainbow. In this video, we will continue on the series of the Beginner's Guide to SDL2 in C. This is the updated version, so this is a brand new version. If you want to follow along with this project, you can go to, see here, you can go to github.com, Programming Rainbow, and this will be called Beginner's Guide to SDL2 in C Updated. Okay, you can clone this repository, you can open it up with whatever editor that you would like, and you don't really need any special tools or anything, you can just follow along. Okay, so, and this has instructions for Arch, by the way, and for macOS. So if you're on macOS, this will work for you as well. Okay, let's look at the code. So I just want to show you the final project real quick before we go any further. So this is kind of what we're building here. This shows that we can make true type font. We can actually make it a bubble. We can bounce it around the screen. We have our player sprite, and we can move it around with the controls, up, down, left, right, or ASWD. We can change the render color. We can actually show the FPS we're getting, which is locked at 60 because we're using delta time and we have a module for FPS. We can also show the position of the SDL that's bouncing around the screen, and that is all text that's generated for us every frame, so we don't really have to do any fancy code for that. This screen is also resizable, so it will automatically resize, to whatever you need to do. We also have music if you want music, if you want to listen to the free software song. And we also have sound effects. If I press S, we'll start hearing, well, we should be hearing S, sorry, not SN, because S is one of the movable.
SDL.
Yeah. And if I change the background color, it says C. So yeah, so this kind of gives you like how to do text, how to do sprites, how to make bubbles around things, draw pictures, make your screen resizable, sound effects, music, everything. So yeah, so where we left off within the last video, let me just, if you just downloaded this project, your source directory will be the final code. So I'm just going to rename this SRC, so I still have it, to SRC2. And where we left off with in video number 2, the last video, is this folder right here is, yeah, sorry, let me just close this. So this is where we left off with in the last video, video number 2. So if you're just starting with this video, you probably want to grab the code from the video number 2 folder and rename it to SRC so you can follow along. So this is where we left off, and there's a couple of edits that I want to make before I forget about them. But I just want to show the code, what it looks like, where we left off with. So I'm going to do we can just build this from the command line. We don't need anything fancy. So I'll say clang if you're on, macOS, and that works on Linux too. And we can say all the source files, and we want the output to be main. Yeah. And now we need to link it to SDL2 and SDL2 image, because we are using an image for the background image. But if you don't know where these are, we can use the package conf for both the header and the libraries. So this will be SDL2 and SDL2 image. I think the SDL2 image is actually capital SDL2. Pretty sure it's weird. It's not, it doesn't follow. And in the second one, we're going to do the same thing here with the package conf, and we'll do the libs. SDL2 and capital SDL2 image. And that should make it where it should work on everybody's system. Okay. And I've messed something up here. Cannot find SDL. I'm pretty sure this is the name of it, but I could be wrong. That's always a strange one to try to figure out what the name of it is. That's definitely not right. So I think I was right the first time. Okay, so let's see what we get as output here. So that's not right. I believe it is a capital SDL. Changing my case on it. Big Fish is like messing with me here. Okay. So that's right. So flags. Okay, that's correct. Source everything.c. We'll output it as main. And we want this twice because we want one for the flags and one for the libs. Dang, I don't have SDL2 in my system. That's very. Very strange. I haven't done anything since yesterday. I mean, I've done stuff, but I haven't removed anything from my system. This is something I'm doing wrong. I just wish I knew what it was. So this is not going to work right here because I don't have the image one in here. Okay, well, this was unexpected. Let's see how I have it in my make file. Maybe I'm just have some typo that I'm just not seeing here. I mean, nothing else is happening here. Is that not what I was doing the whole time? Libs. That should be fine. Okay. But if I use my make file, that uses the same thing. How's this file directory? Oh, this looks correct. That nothing looks wrong here. I wish somebody was watching. Maybe they would know the answer and tell me. Got to be some kind of way this is expanding. So we know this expands to minus L SDL2 minus L SDL2 image. That's what it's expanding to. Let me change to bash because I'm in fish right now, and maybe this is some weird expansion that's happening. Okay, so I don't like the fact that I have this super long name, but okay. So GCC, man, source. I don't normally write this way, but I wanted to show other people how it works, but apparently it doesn't work for me that way either. So we would do the package conf. Things right. C flags, SDL2, and SDL2 image, and same. SDL2 and capital SDL2 image. Okay, that's me. I'm not writing package conf right. Oh, I'm using package config. It must be an expansion, the way that fish is expanding, because this is working. So I'm use fish as my user shell, not as my system shell, but my user shell. And it looks like fish is expanding these. I know I can't put like, let's see if I can group them all together. Because in fish, I can't group them all together either. It's got to be one thing at a time. So I can just get rid of this one. Yeah, it is. Okay. This whole time is the way fish is expanding this what do you call it? It's not subshell. I guess it's a subshell or something. The way it's expanding this command right here, the output of it. Before I knew in fish I couldn't put the C flags and the libs in the same command, in the same expansion. It wouldn't work. But I was only doing SDL, not SDL. I was doing SDL2, but not SDL2 and SDL2 image. So I had to break them up into separate commands. But this time I'm doing SDL2 and SDL2 image. And so those would all have to be broken up. So I'd have to do one for each individual one for the libs and the C flag. So if you're in fish, you're going to probably run into the same thing unless you know how to change the way it expands those. So yeah. But anyway, that's if you're on a system where you don't know where those things are. But also you could just do this. I'm going to exit out of this right now. So you don't have to do this variable thing. You could just do the easy thing, which would be C flags, right? You could just get that output and just like copy it, right? And now I should just be able to go GCC and then just paste it on in here if you don't know where these things are in your system. And that should work. But I have some kind of new line right here, I believe. Yeah, so you could just do that. I'm using the makefile, but I wanted to show people that they didn't need to use the makefile. So like I said, I am in fish right now. So fish is expanding those things a little bit funny. But normally all you need is just to know what the library is. But just in case you needed to know where the include the headers were too, if the compiler couldn't find them on your system, you'd need to use both the C flags and the libs. That finds the include files and it finds the shared libraries that you need to link against. But on my system, it's much simpler because I'm just in Linux and it's not, things are not installed through brew or anything. So for me, it's just very simple. I just need to tell it, -L SDL, I can just do this very, very simply with the C. So that's saying all the C files because I have 1, 2, 3, 4 C files here. I want to build all of them. You can build them separately too and link them separately, but it's not really important for this. And I just need to tell it SDL2. That's all I need to really say. I need to just tell it where the libraries are, and that should work on most systems. I'm not sure if it works on macOS or not, but if it doesn't, then you can just grab the expansion of the whole thing, or you're probably in ZSH anyway, so it probably works in ZSH. I think this is just a funny fish thing that I just figured out that doesn't work, but that also works. Okay, so I spent way too much time on that. That's not what I really wanted to talk about. I was just like sidetracked on why that wasn't working suddenly on stream. I'll probably cut all of that out. So yeah. So if you are on whatever system, you need to know where your files are. So let's just show one last time. You could, depending on how it gets expanded, if you just need to know where your actual include files are for SDL2 and image and the libraries to link them with, you could just say package conf. You could say libs and the C flags. Well, we'll do it separately. So you could say SDL2, that's the one with the lowercase. And then for image, it's uppercase, SDL2 image. And that gives you the libraries that you need to link against. And if you were looking for the include files, because maybe your system didn't know where those were, it would be C flags. And it should. Otherwise, you have to manually put this stuff in. So what you really need here is just this one right here, the SDL2 one, which would be in opt homebrew, something like that in macOS. Anyway, that's enough of that. I'm just going to use the makefile after this. So, you can do it manually, but the makefile just makes it easier. And we'll talk about the makefile in another video. So let's go back to where we were here. Let's just show where we were in the last video real quick. So I'm going to do a make clean debug run. Make clean cleans out whatever file I made, the binary, which is this beginner's guide binary and this build directory up here. It deletes all that, and then it does a debug build. That's for me to know if I have memory leaks or other problems, and then also run the project. And this is where we left off with. We have a background and we have an icon, but we can't resize the window and we haven't seen any colors yet. So that's what we're going to do on this one. So let's go over here, and we've already seen this SDL create window. And last time I said I was just setting the flag to shown down here, SDL window shown. But we can actually make this window resizable if we also use the resizable flag. So let's do that. No, I'm going to do that real quick, but then I got to go back because I just remembered a couple cleanups I forgot about. So right up here in the Windows flag, we can add that other flag to it right here by using a single pipe. This flag is just a number, and this is a binary OR operation, which actually combines the bits together. So we'll say SDL window, is it resizable or something like that? Resizable. Okay, and that should, and it puts spaces here. You may need those spaces, so you should put those in. My LSP did it automatically. So this should just make it resizable, but it's not going to be quite right. So we resize it, but look, the image is being squashed around and stuff. So that's not really what we wanted, right? We kind of want to keep the same aspect ratio if we're resizing it. So let's deal with that. But before we do anything, let's change this right here. this background and icon. Let's change this to random colors. You can spell it with a U if you like. And also resizable. And there's a couple little cleanup things I wanted to do before I forget. So in main, right here, if this fails, we never allocated anything on game. Game is already free. There's nothing there. The pointer is null and everything, so we don't need to free it here. This doesn't cause a problem because we are checking for a null pointer anyway immediately, but this is unnecessary. So I'm going to put it in here because it's only allocated in here. And also the other thing that was a bigger concern to me is I want to put game to null. I don't want to have it because I could potentially add more code later, and now I have this freed pointer, but the pointer still has an address. So this is a big no-no. So like whenever you free anything, set it to null immediately. Even if you're going out of the scope of that function, just set it to null because you don't know later on you might come back and do something. So that's a big no-no. I really messed up on that one. And let me check something else. So I have a magic in when we load the icon here. I just want to pull this out of here. This is like a magic value I have to find in my code. So what I'm going to do is I'm going to say window icon, and it's going to complain because it doesn't exist yet. But I'm going to go into main, and I'm going to give it that window icon. So I can just, if I ever want to change it, I can change it here. I don't have that magic value in my code. This is not a bug or anything. It's just a little annoyance of mine. I forgot to do it. And make sure that there is no, semicolons on the end of these pound defines. So if we go back into here, it's not complaining anymore. So it's still good to go. And now we can change the icon to anything else we want. We just do it from the main.h file. That's fine. There was probably something else. I feel like when I was freeing something. So I'm freeing the game. I think when I'm allocating the game, maybe I did it right here. So yeah, G is null, G is null. So that looks fine. Oh, this right here. I don't want this here. That sets the game to the running state, but I want that to happen when I create the new game. So let me close this so it looks bigger. So when I'm in here, when I'm making the game new function, at the bottom of it, if it's all good right before I return game, I'm just going to set it to running state. That makes more sense to be there. And I think that's all the cleanup things that I forgot about. So now we have this window that's resizable, but it's not resizable the way we want it to be resizable. Like you may want it to be stretching around, but I don't want it to be doing it that way. So how can we deal with that? So we can use a render. We can set the logical size of the render itself. So we're kind of setting the window size. So the render is just like stretching and scaling to that. That's the canvas we're painting on. But we can say, you know what? No, I actually want the render to be this size. So when we change the window size, it's going to, change the window size, but the render is going to try to keep its aspect ratio. Okay, so we're going to use this. So this is returning a 0 on success and a negative on failure. I'm not sure if we need to check that. We'll just check it. And what we can do here is we can just put in our width, our window width, and a window height in here as our width and our height. And then when we ever change the window itself, the renderer still wants to be the same size logically. So I'm going to grab this. And this needs to be done in a... this needs to be done right after the render, I believe. Function uses viewport. On this one, I think we can do it anywhere. I'm going to put it right after the render. So I'm going to put this in the SDL, the init SDL function. So in init SDL, we are creating the render here. And now we have a successfully created render. So right here. And this is returning 0 on success, which is 0 is like faulty. And anything else is something bad happens. So we can just wrap this in an if. So if we get anything out of this, something bad happened. right? And we'll just put something here like this. We can say setting, whoops, say setting logical size. Setting render logical size. Or it's not renderer, it's render, I guess. Sending render logic size, and we'll still get that out of there. So in here, so we need the pointer to the render, which is G render. And for the width, we'll do window width. It's already something that we've defined. And window height. Spelling all these wrong, ain't I? Windows backwards. Okay, window width and window height. So I'm setting the logical render to these. So even after we change the window size, it'll still be there. And if anything happens on here, we're bailing out. So let's try that. I'll do the debug run. Okay, so now what happens when we change it? Okay, so this is nice. The image is shrinking, but it is staying the same aspect ratio. So I like that. And let's do, whoops, that's not what I wanted to get to. There it is. So we have this, we set the logical size of the render. We can also set hints. So we can't see it on what I'm doing right here because I'm already using a big background image. But if we were to use a smaller image and it was scaled up, it was made bigger, like say our game was small and we were making it much bigger, you may want it to be smooth or you may want it to be pixelated. If you're doing like a pixel art game, so each of your sprites is like 8x8 or 16x16, and you want to make that full screen, you don't want those pixels to be all muddy and blurry. You want those sharp pixels. You want that thing to be larger now, but still be crisp, kind of, because you're going for the pixel art style. But also you may not want to do that. So we can set an SDL hint. Let's see. I may be talking about the wrong thing. Let me look at this real quick. So the scaling quality. So if we set it to 0, when we make things bigger, it's going to be kind of still pixelated. If we set it to 1, it's going to be blurry, and 2 is blurry as well. But it depends on what kind of art you're doing. You may want that. You may want the smoothing happening, or you may want the crisp pixelization. So this SDL hint render quality is actually set by this function here, this SDL set hint. So we put the quality in here, and then we put the value after it. So here is the quality, or the thing that we want to set, and the values are 0, 1, and 2. So what I'm going to do is I'm going to pull this out into its own like render scale quality kind of deal, so we can just change it in the main header file. But let me just show you kind of what this looks like. So I'm gonna change the image to a smaller image. I'm not quite sure what you're asking. Right. Right. Browse. I'm not sure. Are you talking about writing a web browser in C? Or you're talking about writing some application that will be in a web browser in C? If you're talking about writing a I have no idea what that game is. Let me look. I'm guessing this is not written in C, right? This is like written in JavaScript. So you're trying to write a server. Yeah, I have no idea how this this works. Find multiplayer game. So I'm guessing the game is all in JavaScript. So that's not C, but like if you're talking about the server part of it, yeah, I have no idea. That's something you'd have to kind of play around with and see where you end up with. I don't know what the server side of it is written in either, because it's what is it? It's it's a mobile game, right? Okay. Oh, so you want to make like this same type of game in C? Like you want to make a similar game like a version of this in C. So I don't know the exact game because I haven't seen it before. Is there a video of it or something? Let me mute this because I don't own that audio. I'm sure you can you make a game like this in C. So there is like different aspects of it, like the the images with all the what it's doing, but like it's not. This is not like a very difficult thing, I think. But like the basics of it are probably simple. When you try to get to the full blown version of this, where everything else is involved, like what information is being sent and received, and the multiplayer part of it, and um, the different information being displayed on the screen, it gets more and more and more complicated, right? There's probably a team of people, but just the a simple version of this, like where it's like is it kind of what do you call it, Risk type game with bubbles. So there's no reason you can't make anything like this. I mean, just start small, try to do basic things, and then just keep adding on to it. That like there's no reason you can't build anything. Yeah. So if you write a game in C for the browser, it will never be in C on the browser. Your code is going to be compiled to something else. It won't be C. So you write it in C, it's not going to turn into a binary. What you're going to do is you're going to cross compile it into like WebAssembly through what's it called now? I forgot the name of it. It's going to end up as JavaScript or WebAssembly at some point. It won't actually be C. So if you're trying to write JavaScript for the browser, you might just write JavaScript for the browser. WebAssembly, though, yeah, you don't write WebAssembly directly. You write something like JavaScript or Rust or C or something else. I played around tiny bit a long time ago with it, but I'm kind of so far away from the browser that I don't really pay attention that much to the browser. I'm always doing something like much lower level. But there's no like that. That would be something like if you had it locally working in C, you would convert that to WebAssembly. But when you're talking about in the browser, you're probably talking about the multiplayer aspect of it, which then that's going to be kind of browser stuff right? Or however your server backend is written. So that's going to start to get way more complicated. And then, like you might be writing parts of it in one language and parts of it in another language. You might be using Go or something like that for parts. And you might have parts of it in C, and it's all going to be like WebAssembly, but your server might be doing other things. But what I would do is I would just try to make a simple version of something, like make a local thing with like these kind of the ideas of the bubbles and how it's like taking over. Do like pick one aspect of it and try to build it. And if you get that built, then give yourself another target, add something else to it, or try to add networking or draw the animation differently or something like that. You basically don't try to say, I just want to build this entire thing. Say, I want to build like this simple version of it or this aspect of it. And then, right. That's what I end up doing with projects, because if it's just something like too hard, then you're like, oh, I can never do this and it'll never be done. But if you do something that's like within your range or slightly out of your range, you can complete it. And then you can either switch to something else, or you can add on to what you're already doing until you keep building and building and building something bigger. But yeah, there's like you can do these things in any language you want, but there's probably lots of aspects to this game. You know, the multiplayer and the information being sent if this is an online thing. So that gets more and more complicated. Okay, let's get back to this. So let me show you this. If we're scaling something wrong, so I want to change the background image actually to like a smaller image, because I want it to be drawn too big and look bad, basically. So the background is over here, and let's just load that C logo. Okay, so see, this is for one, it's you know, this is not really pixel art, but basically it's that small image. It's being stretched to the wrong size. You know, this is not the right aspect, because the remember my logical render size is 1280 by 720. This that is not the aspect ratio of this sprite. So the reason why it's being drawn wrong is not because of the window sizing, it's because I'm telling that sprite to be drawn wrong, to be drawn in the wrong aspect. So ignore the fact that the aspect is wrong right now. Let's just look at the fact that it's pixelated. Okay, so we're going to change that. So we're going to use this function, this set hence, and this returns a bool, which is like the SDL bool, SDL true or false, and returns true if the hint was set. Okay, so we can check that as well. And is this done? Okay, this doesn't say it needs to be before the... There was some bit that needed to be before. Let me check on code. It does say it's before the render, yeah. So set the hint for normal priority. Hint will not be set, there's an existing override. So I have a feeling this has to be set before the render, but I don't see it directly being set. It needs to be sent before the render. Yeah. So I do have this set before the render. I could be wrong on that. It may not matter if it's before or after the render, but I'm going to set it before the render. So we're going to use this function right here. And this is not the code that we're in right now. We are in source code. So I'm going to set it after the window, before the render. And it's returning something. So what I'm going to do here is, I don't know how this SDL true and false is set under the hood. So I'm just going to compare it. So I'm going to do an if, right, on this function. And I'm going to say equals, it's false on failure. returns true if the hint was set. Yeah, so I'm going to say if it equals false, then we're going to do something, or we're going to shut down, basically. So the hint name that I want to set is right here. So that's the constant right here. And the value can be 0, 1, or 2. So I think by default it's already 0. So let's change it to 1. And we'll just throw some error message about we couldn't set the hint. Setting hint value or something like that. Okay, so we're setting it to 1. I believe by default it's 0, which is the pixelated version. So if we look at this now, we should get this smoother version. Yeah, you see how it's like smooth? And for this, it's muddy, but if you had like a nice quality image and you just needed to make it bigger, you may not want it to be pixelated. So, but this is like an extreme case. Okay, and there's also a 3 version, or a 2 version, sorry. So we can go here, and we don't need to clean every time. And it says it's slightly better. For this extreme case, we can't really notice. So I think I called this scale quality, probably render scale quality. Let me check what I called it. I want to keep my names the same. So scale quality, render scale quality, and yeah. So in main, I'm going to add under the render flags, render scale quality. And we're going to just set it to, actually 0 is what I want to use, but you can set it to whatever you want to use. So we have this, and I'm just going to drop it in. So I don't need to go hunting around the code to find where this is at right here. Okay, so we're setting this before the render, and this allows us to either blur things or let them be pixelated when they're scaling. And we're setting the logical size here. Okay. And we could actually make the window be scaled to a size that we want it to be, right? So again, the image I'm trying to display is like 120 by 120, right? So we can change the size of this real quick to see it in the correct aspect ratio. Let's just say it's 720 for both because it's like a square image. Okay. And this is correct now, but it's the 0 version, the pixelated version, yeah? But what we could do is we could also have another one here, which is like window scale. Right? And this could just be like a multiple or something. So let's say we had this. Let's say we know what we want the rendered in the game to be, but maybe we want it bigger. Like if you had a small game that was like, this is literally 120 by 120 is the image I'm showing. But I don't want to open a window that's actually 120 by 120. I want a window much bigger than that. So I could say like scale it by 5 or something like that, right? So this will still set the render to this 120 by 120, but the window will be much bigger. And I'll show you what I mean, because we already are using this in the setting the window size. So the window size is already up here. We're setting the window size here, right? But that would be 120 by 120. That'd be way too small if you were trying to scale a game up, you know? if it was meant to be a small game and you want to scale it bigger by default. I mean, you can always resize the window too, but I'm just saying by default, the way it opens. So we could say window scale, and we could just multiply them. Okay, so we multiplied, spelled window wrong. So we multiplied them, but the renderer is not. The renderer is how the logical needs to be. And so that's going to be 120 by 120, but the actual window is going to be scaled bigger. So what we should see is basically something that is 600 by 600 or something like that. But the renderer believes that this is a 120 by 120. So if you had all your game logic set to this 120 by 120 for collisions and movement and everything else, you can just scale the window now. This is just pre-setting the scale. And you know, like if it was a small game, you know, it was like this big, but you want it bigger, you can just set that to a larger scale. So that's pretty simple. And we already know that we can change the way that it is smoothed or not by setting this to a 2. There's also something called integer scaling. So now it's smooth, right? And again, this would be if you had high quality images, but you were just changing the size a little bit bigger, a little bit smaller, and you wanted to look smooth. This is an extreme version I'm showing. So it, you know, doesn't look good for this, but. Okay, so another thing is what if you only wanted to get larger by increments? So if this is 120 by 120, what if I wanted to stay 120 by 120 until I had enough room to go to like 240 by 240, and then it jumped up? So we have a function for that. This is a render set integer scale. So if we do this and we enable it with the SDL true, that's what the SDL bool is. It would be an SDL true here. So if we enable this, it would make it where it'll jump up in size. Okay, so it'll be scaling by 120 each time. So basically, even if you make the window bigger, it doesn't get bigger until there's enough room to scale it. And this one is 0 on success. So let's just grab this function here. And this will be in the same thing, where below the setting the logical. And this one returns 0 on success. So anything other than 0 is a failure. So we'll just check that with the if. And the render is just grender. And this one here is just a SDL true or false is what this is. So let's set it to SDL true. And let's dump something in here for the error message. And we'll call this setting integer scaling. So we got setting integer scaling. And I'm going to pull this out in a second. I just want to see what it looks like. So it looks the same, right? But let me start shrinking it down. See that? See how it kind of pops down to a smaller size? So it's initially 120. And as I make the screen bigger, it doesn't get bigger until it has enough room to double its size. Right there. And now it'll probably do it when it can triple its size. Should be around here. There we go. So this is if you want it to be some kind of multiple, you could turn this on or off, right? So I'm going to leave this in, but I'm going to take this out, and I'm going to call this like a scale int. So I'm just going to cut that, and I'm going to say render scale int. That's what I'm going to call it. And so over here in main, int, and I'm just going to set it to, I actually want to set it to false because I don't want it to do that, but you may want it to do that. So you can set it to true. right here. And we also need to save it in here. So we've done all these things, and I think I set it to false now, so it should scale smoothly. Yeah, okay. So now you can have control over your game, do it if you want it to be smooth or however you want to do it. But let's change the background to a random color. And we're going to make it where every time we press a spacebar, it changes to a new random color, okay? And we're going to run into a little bit of an issue here. It may or may not be an issue, however you think about it, but with the fact that we are doing this window aspect ratio scaling thing. So to get a random number in C, it's pretty simple over here. It's just part of the standard lib, std lib, I believe. Can never remember. It's something like that. It's already like it's already in the standard lib header. So we have two functions that we care about here. We have rand and srand. So if we were to just use rand, we're going to get the same random number sequence every time. So if I just put rand in my project, let's just say I get 5 the first time. The second time I get 120, and then 1,000,000, 10, and then 4. If I start the game again and I do rand again, I'm going to get 5, and then 1,000,000, 20, and then 4, or whatever. I'm going to get the same sequence every single time. So we need to set the seed for it, because basically it's a pseudo random number generator. That's how all computers work, pretty much. And it can make this sequence of seemingly random numbers, but it always starts at the same spot. So basically you want to start it at some other spot in the list, so it looks like you're getting random numbers, and that's called the seed. And the way that they seed it is with time. So just grabbing the time, the current time, and seeding that, so it starts somewhere down the list based on whatever time it is. That's pretty simple, so we're going to do that. So this is a new header file. We don't need the standard lib, but we do need time. So I'm going to include time.h here. And then in game, when we create the game, the new game, down here at the bottom, probably before we even turn it to true, it doesn't really matter. But here is where I want to do srand. So if we look at this, srand, we open it up here, it says it needs an unsigned int as the seed, and it returns nothing. Okay, but let's look at time. This is going to complain here. I'm just going to do nothing with that. So time, now time returns time t, which is not necessarily an unsigned int. It depends on how strict your compiler is. Time t should be. Might not be the exact same type. So in their version here, they're not casting it, but I know I cast it. And if you're just using a basic compiling, that's fine. But if you're using very strict compiling rules, like in the makefile, this probably needs to be cast to an unsigned int. So let's try what they're doing. So this is time, and we put null in here. And that should be fine, right? That's going to seed our random number generator. And let's just see if this builds. So I'm going to say make clean, and that's it. And then I'll do a make. Okay, and that's not strict compiling rules. Now let's do my strict compiling rules. And we see here we have a problem here. It's a long int is what it is. Okay, so we're going from a long int to an unsigned. So I prefer to use the strict compiling rules, so I'm just going to cast this to unsigned. Oops. And now it should stop complaining about that. And it's good. Okay, so this is seeding our random number generator. Now we can just call rand whenever we want. We get a random number, and we can just use modulus, or we can cast it. So I'm going to show you how we can change the color of the render. So we can use set render a draw color. So this sets the draw color of the render. And what's happening is whenever we do the clear, the render a clear before we do our drawing, that's actually clearing it to the render or draw color. So by default, it's black, but we can change it to something else. So then when it clears the screen again, it's going to be that color. And I'm not going to check the error on this one because it's happening in the draw loop, in the game loop really fast. So I'm not checking this. It's okay to me if this fails. And since it is the render draw color, which will just be used as the background itself, not as making a rectangle or something else, we're going to just set the alpha blend to 255, meaning it's opaque, it's not see-through at all, because it wouldn't do anything for this instance anyway, even if it was see-through. So we're not setting that. Okay, so yeah, I'm going to put this in. This isn't going to end up being changed, but basically I'm going to make a new function. And I think I called it like random color. I'm going to look at my code just so I can give things the same name because I want to be down here. I don't want to use different names and then I'm off course. So we call this game render color. Yeah, that's fine to me. I'm going to put it above here. And this is not going to return an error. So I'm going to say void game. It said render color, right? Render color. And I need to go struct game, G is a pointer to a game struct, like that, because we need the render. And now I need these random numbers, right? So G render is my render. So for red, green, and blue, I don't need to do anything special. I don't even need to use modulus. Like I can do that. I could say rand, and I could say mod, like, was it 256? Yeah, I could do something like that, right? Let's try that actually. For the last one, I'm just going to put 255. The reason why I'm using 256, and I could be wrong on this, off the top of my head, I believe modulus is exclusive on the top end. So God, I may be wrong on this. I was programming Bash for the last couple days. We'll find out. And this is a function call. I don't know why I didn't do that. For the last one, I'm just going to put 255 here, which is the highest number that you can give for an unsigned int, which is what this is looking for. Let's go look back at it again. So these take uint 8s, which are unsigned 8-bit integers that go between 0 and 255. Okay. And so the last one is the alpha, and I'm just going to have that be 255. So these are all modulus. Yeah. So for one, I want to forward declare this as a prototype right above events. Because again, my strict compiling rules will complain about that. And then we want to add in something just like the escape. I'm just going to go ahead and copy this escape right here and add a new one in. But I want space, not escape. So it's literally just called space. And for this one, we're going to call that function game ran. Is it render color? I should have called it random. And color. Let me check again what I called it originally. Game render color. Render color. Render color. I'm going to call it random color. That because yeah, I am setting the render color, but I'm also setting a random color. It is the render color. Okay, so render color. So all I did was just copy the space one, this one, or the escape one. This one's called space. I'm calling this function that returns nothing. It's a void. And I have a break here after it. So this all still works. Let's try that. Okay, so from int to unsigned. So I'd have to cast these. I wasn't going to do this version. I was just going to show it work. So let me just cast these real quick. Yeah, something like that, maybe. This becomes like, this is nonsensical because we don't need to do any of this. So let me just back up for a second here and not even use the modulus because it doesn't matter. What all we really need to do is cast this number to a uint8. That's the real answer, because it's an unsigned integer. When it gets cast, it's gonna act like modulus anyway. It's gonna roll over until it's the correct number, you know. Not the 255, but this one here. This uint8 is defined by SDL. Okay, let's make run. Okay, so we should be able to change the background color. See? So this image I'm loading here has a transparency, and what's behind it is the render color. So every time I press space, I get a new color. So I want to change this back to the original image because we're already done talking about scaling and all that stuff. So I'm going to do that real quick, and then we're going to see a problem with this. Well, we could have already seen it, but I'm just going to change it first anyway. So this one here was background. And also we need to change the size of the game back to it was 1280 by 720. Let's say make clean. Oh, I put the scale on it. That's my bad. There's still a scaling factor. Let's just scale it by 1. Okay, so back to where we were, and this is still working. Yes, we're all good with this. And now when we change the background color, the part that I don't like is the render color is on everything, but the image is being letterboxed. And when we have logic, we'll see stuff bouncing around inside of whatever the letterbox, but the render itself is not being letterboxed. It's just drawing the color. So I don't want that. Because if you have a game that has a specific border of the game and you're changing the size like this, you kind of prefer the bit that is not part of your game, that the logic's not going to do, things are not going to be drawn on and everything else. You probably just want that to be some black border or something like that. So this is just drawing to the entire render. So what I'm going to do is going to make it slightly more complicated. I'm going to clear the render to black, and then I'm going to draw a rectangle that is going to take up the entire render, but it's going to be the entire logical render, not the render. So that will give us what we actually wanted. Let's look at here. And so I'm going to hold the random color. I'm going to hold it in a color, which is just a struct of an RGBA. So I'm just going to use that as a kind of a holder for whatever the color is, because I'm going to be switching back to black. And I'm going to use SDL render fill rect. And right here where it asks for a rect, I'm just going to put null in there. When null is in there, it's going to be the entire render, but it's the logical render, not everything that's rendered. So yeah. So what I'm going to do is, let me make sure I'm in my right code here. Not here, but here. I'm going to add an SDL color in here. Color, and I'll just call this the like back color, the background color, something like that. So we have this color. And so now when we go into our function, we change the render color. Yeah. We're not going to change it directly. Instead, what we're going to do is we're going to set the RGB of this SDL color that we just made. So it's going to be G back color R equals, and then we'll do the casting, the uint 8 on this, and I'll just do this. Sorry, this needs to be rand. So I'm just going to yank that and copy it a bunch of times, paste it in. Okay. And I probably don't need to set this last one to 255. I'm just going to do it. So this will be alpha. This is red, green, blue, right? So I'm not going to do this other part in here. I'm just going to do that. Now when we are actually clearing the screen, it's going to clear to whatever the render color was set to. And this is a problem because I actually want to clear it to black and then draw this rectangle. So we do need to set the color to black. So I'm just going to set it here to zeros. And I think the other one can be 255. It doesn't matter. So that's going to get our clearing to be black. And then after it, I'm going to set this to those colors, the RGB. So this is G background color dot R. Whoops. I was trying to copy. It. Background color R. Background color G R RG. And this last one will be B. Whenever you're using a rect, you always have to set the color before. You might set it back to black afterwards. So this is always a thing. B. Okay, so we set the render color to black. We're clearing the render. Now we're going to set it to the color we want. And now we're going to draw a rectangle. So right here, SDL fill rect. And I'm not going to check. This is in the game loop, so I'm not checking this. If it doesn't draw for a frame, I don't care. So the render is grender. And now for this guy, we do not need a rectangle. We can just say null, and it's going to use not the whole render, but the logical render. So what's going to happen here is it's going to clear it all to black, and then it's going to draw a color, but only for the logical render. So now let's resize, and we see the black bars now. And you may or may not want this. Like this is, I prefer it because later on when we have things bouncing off the screen, it makes sense why it bounces here and not over here, because this is the logical game space, whereas this is extra part of the window that doesn't work for this aspect. Okay, so let's see here. Let's just cover everything we've done. So we did clean up a couple things. We changed the way this is inside of this if statement, because if it's outside, it doesn't make sense. It still works. It doesn't hurt anything, but it's not good. This is a bigger problem, making sure we did the game null here after we freed it. We took out down here when we're doing the surface, we pulled this out, this magic string, and we put it into the main.h, so we can just change that if we want. And then we started playing around with scaling. So we went into main.h, and we added with a single pipe, we added the resizable. So this allows it to be resizable. But when we did that, we got the wrong aspect ratio. So back in init, so to make it the right aspect ratio, we set a logical size, and we just use the window size, okay? But so I could make it scalable. I added a scalable thing that multiplies by size here. Right now it's actually set to 1, so it doesn't do anything. But again, if you had a smaller game that your entire game window was only like 240 by 320, but you wanted it to be big, you could do that kind of deal. That you can add a scaling option here. But this allows us to now have the correct aspect ratio. And we could also make it where it scales up for a multiple, for an even multiple. So if your game size was like 100, it doesn't go to 110, 120, 130. It goes 100 and then 200 and then 300, something like that. So this, and we pulled this out. This is in the main.h, and basically this is an SDL true or false. So right now this is set to false, but if you did want it to scale integer wise, you set it to true. And we have this hint here. This deals with the way that when images are being drawn not to their native size, so they're being drawn bigger or smaller, how it's scaled. So, and this can fail. If it fails, we get an SDL false. So that's what we're checking. But we are setting a hint, and it's SDL hint render scale quality. And we pulled out this quality into the main.h, and this can be 0, 1, or 2 as a string. So it's right here, render scale quality. I have it set to 0, which is pixelated. 2 and 3 are smoothing or blurry versions. And this is the other scale int right here. And we've pulled that window icon out here. Let's see, in game, we did add this function here that is game render color. Hopefully I forward declared it. Game render color up here. So that's... We're just using rand and casting it to uint8. So we always get a uint8. And for the alpha channel, we're just setting that to 255, which is maximum. And that's on the space key. We're running this function on the space key. And that just populates this background color, but we actually use it in the draw. So when we go down to here to draw, we set the draw color to black first to clear the screen. And then we set it to the color that we're holding on to. And we draw a filled rectangle. So the next time it comes back around on this loop again, it's going to set it to black again, clear the screen. And that's just because I wanted the black borders. If we were actually just drawing a picture and not using a render color, it would be black behind it. But because we're setting a render draw color, this was the way to work around that. We also took right here, the is running bool, and put it where it belonged up in the game new here. And this is the way we are seeding the random number generator. We're doing it with time. And since this is not an unsigned int that comes out of time, we are casting it because depending on how strict your compiler is, it may complain about this. Okay, I think that's about everything. So if you have any questions, just let me know in the comments below the video, and I will try to answer them, or maybe somebody else will be able to answer them, or maybe you have some, maybe you saw some mistakes I made and you want to correct them, you can do that as well. So hope you enjoyed that and have a good day. I'll see you later. Bye.